Hi and welcome to Stellarphile, a look at the weird and beautiful stellar neighbourhood that we live in. Of course you know your address, but what about your stellar neighbourhood? Could you point the direction to Proxima Centauri or Betelgeuse? As amazing as it is to look at stars through telescopes, the visible light that makes it to the surface of the Earth doesn't tell the whole story. Fortunately, in the 21st century we have some fantastic simulations and online tools to help us to understand the nature of the stars around us. In Stellarphile we'll look at the picture that these simulations build up together, so that star by star we can come to see the sky as the exciting, violent and active environment that it really is. Zeta Leporis, or Leporis 14 as it's also known, is a Class A star 70.5 light-years from our solar system. The star appears directly below the left leg of Orion, in the constellation Lepus. Zeta Leporis is so bright that it can be seen with the naked eye, with an apparent magnitude of 3.5. Other A-type stars are among the brightest stars in our sky: Altair, Sirius A and Vega. However, the star itself is 14 times as bright as our own Sun, even though it's only 1.5 times the mass and radius. It burns hot, possibly as hot as 9,700 degrees Kelvin. Like all stars that burn this bright, it will burn through its fuel much faster than yellow stars like our own. It is only a couple of 100 million years old, and is estimated to be in transition towards a subgiant type. Zeta Leporis was the first system other than our own to be found to have an asteroid belt. It was first observed in 1983, but in 2001 the radius of the belt was estimated again at 5.4 astronomical units. The asteroid belt is estimated to have a mass around 200 times the mass of the asteroid belt in our own system. The dust from this belt is heated, and this is the reason it can be observed. It emits infrared radiation that's been detected by Earth-based telescopes. Calculations seem to show that this dust should have been swallowed by Zeta Leporis within a short period of time. However, something seemed to be replenishing the asteroid belt around the star. It might be something like the replenishment of Saturn's rings by volcanism on Enceladus. Another cool thing about Zeta Leporis is, based on its movement, we can calculate that it passed within 5 light-years of our own star around 1 million years ago. It's been proposed that Zeta Leporis is a member of the Castor moving group, a collection of young stars which are estimated to share a common point of origin. These include Vega, Alpha Cephei, Alpha Libri and Castor. Although these stars are considered to have a common origin, they are not gravitationally bound together and are dispersing in different directions. The Castor moving group is a subject of current research, and further observations will help us to understand Zeta Leporis' recent origin. The huge energy output of stars like Zeta Leporis might very well create some incredible effects. Stars like Zeta Leporis and Sirius, of a similar type which is much closer, will give us a great view during their accelerated stellar evolution. One of the oddities of the simulation of this system in Space Engine is that it's orbited by a large gas giant planet, which creates a barycenter around which the A-class star orbits. This is procedural data, but it does correspond with a version of the star in Elite Dangerous, although the barycenter in Elite is caused by 2 smaller, cooler stars. Although it would be great to see the asteroid belt reproduced in the Elite or Space Engine versions, the richness of the system in both these versions perhaps signals the interesting planetary system we might find when we one day are able to travel to Zeta Lep. There's a lot of information freely available about astronomical observations online. You can check this out yourself on excellent websites such as Simbad. SkyMap.org gives a good photographic map of our sky too. One of the best simulations to give a sense for the geography of our Milky Way and universe is Space Engine, and that's what I've been using mostly in this video. Again, this is freely available, but you can donate to support the project. I'll put a link to all these resources in the video description. Thanks for joining us, and don't forget to subscribe for more science and astronomy related videos.